This first problem is an integration by parts problem, so we just need to select our u, which in most cases is the x term, unless of course there's an ln in it, and the dv by dx is e to the x, which means that v is e to the x, and du by dx is 1. So this is uv minus the integral of v du, and du by dx is 1. So that simplifies or finishes off to be minus e to the x plus c. Don't forget your plus c. Okay, this is a bit more meaty. Clearly a substitution problem since we're given the substitution here. So let's make a start with that. So if u squared is equal to 2x minus 1, then we need to differentiate it. So I'm going to implicitly differentiate it here. So 2u, so I've differentiated with respect to u, times du by dx is equal to 2. So it's differentiated. And that rearranges into u du equals dx, because the 2's cancel. Now, we've got limits here, so it's probably a good idea to mess with the limits too. So when x equals 5, u squared is equal to 2 lots of 5, which is 10, minus 1, so that gives us 9. Therefore u is the square root of 9, which is 3. And the other limit, the lower limit, when x equals 1, so I'm getting these from up here, u squared is equal to 2 times 1 minus 1, which actually is 1. And the square root of that is also 1. So we've got our new limits. So let's stick that lot in and see where it takes us. So first of all, we've got our new limits between 1 and 3. We've got nothing for the 3x at the moment. On the bottom, well, u squared is that, so this bit here is the square root of u squared. And the dx turns into a u du. And take your limits with you everywhere, don't lose them, even when they're trying to disappear. And then we've got u du, and you can see that they cancel, which means that what we really need is a substitution for the x. So perhaps if we rearrange this, we'll get that. So x equals u squared plus 1 divided by 2. So we can modify this. So we've got 1 and 3, and then we've got 3 lots of u squared plus 1 over 2 with respect to u, which is looking a lot nicer, especially since we can take 3 over 2 outside of the integral sign and just leave ourselves the u squared plus 1 inside it, and that's considerably easier. Now, we're actually going to perform the integral, so we move to square brackets, and that goes to a u cubed over 3, and then 1 turns into a u between 1 and 3. Don't forget your limits. And now it's just a question of carefully substituting in those limits. So we've got our 3 over 2, so then there's 3 to the power of 3 over 3 plus 3 minus 1 to the power of 3 over 3 plus 1, which is 3 over 2. Now 3 cubed is 27, divided by 3 is 9, 9 plus 3 is 12. And then over here we've got 1/3 plus 3/3, which is minus 4/3, which gives us 3 over 2 times 32 over 3. They cancel. 32 over 2 is 16. something which you can also verify on your graphics calculator. Okay. Well, whenever we've got trig functions lying around, we should always consider appropriate trig identities. And of course, you can see the main difference here is we've got a cos 2x on the bottom, whereas on the top we've just got x's, and that should be a real clue that we've got to bring in the double angle formula. And of course, this top one here is very reminiscent of this. The sine of 2x equals 2 times sine x cos x, which of course means that sine x cos x must be equal to a half of sine 2x. So that's exactly what we're going to do. So we're just going to write the top as a half sine 2x, and the bottom I'm going to write as cos 2x plus 3 to the a half. Now, the half can come outside the integral sign. Makes things a bit clearer, doesn't it? And then we've got a sine 2x, and that's a cos 2x plus 3 to the minus a half. And at this point you can possibly see that there's a relationship here. So if you differentiate cos, of course you get sine. Well, you get minus sine, don't you? But you can see there's a sort of a relationship there. So this is a standard pattern. We could probably do it, well, we could do it with a substitution. We could use u equals cos 2x plus 3 and proceed from there. But I'm going to just, since I've noticed a standard pattern, I'm going to try y equals cos of 2x plus 3 to the half. Notice I've added 1 to the power, which means that dy by dx is going to be equal to a half. That comes down. Now, cos 2x differentiates to negative sine 2x, so it's negative 2 sine 2x. And then of course I've got the cos 2x plus 3, and that drops down to minus a half at that point. So that gives me, they cancel there. I have equal to negative sine 2x cos 2x plus 3 to the minus a half, which of course is very similar to what we've got up here, except for the sine and the half there. So all we really need to do is, if we just box that lot off and indulge in a brief arrow here, so that equals a negative half times cos 2x plus 3 to the power of a half, plus c, of course. And you can check that by, of course, differentiating that and seeing if you get that. And I know that if you differentiate the stuff in the brackets here, you'll get this. So having that negative sign there will flip the sign back to being positive, and then the half will reflect this thing here. Okay, last question. Clearly the partial fractions, and also incredibly top-heavy looking. So here we go. Let's do the division first of all. So we've got to divide x cubed plus 2x squared plus 2x squared plus 0x plus 2, and we're going to divide it by x squared plus x. So I've just multiplied these out. So x squared into x to the 3 goes x. x multiplied by x squared goes there, x multiplied by x gets x squared. Then we subtract, that disappears. There should be a plus there, shouldn't it? 2x squared minus x squared is just plain old x squared. Bring the next bit down. X squared into x squared goes once. Then we multiply both of these by the 1, so we get x squared plus x, which gives us minus x plus 2. And that means that what we have is the division x cubed plus 2x squared plus 2 all over x squared plus x is equal to x plus 1, that's the bit at the top, and then plus the remainder, which is minus x plus 2 over the divisor. And then we do partial fractions on this bit. Minus x plus 2 over x squared plus x. And of course we know what that factorises to, so it's going to be a over x plus b over x plus 1. Factors come from the original factorisation, if you didn't notice. So of course that means that minus x plus 2 is equal to a times x plus 1 plus b times x. So if we stick in x equals 0 first, we get 2 there and a there. If we stick in x equals negative 1, then rather carefully you would watch out for the signs here. You've got minus 1 plus 2, so that gets us 3. The a disappears and we end up with minus 1 times b, which of course means that b equals negative 3. So having done that, we can now rewrite this integral as integral of x plus 1, that's this bit here, plus a, which is 2, over x, minus 3, because that's our b, over x plus 1 with respect to x. And then we just go through, and it's pretty straightforward. We get an x squared over 2, plus an x, plus a 2 ln of x, minus a 3 ln of x plus 1, and, as always, the plus c. Well done if you got that.